Alright, this is the second video for the FemLabs. So here we're gonna make the 3 or the 4 joints, or basically we will connect the meshes together. So we call that Fem assembly. And the element we'll be using is RBE2 and the C-bush. The RBE2 is the spider looking element in the picture. So basically Dr. Zarda will call this spider element. All right, we will start from the last time, and you should open your Fem because we will be doing pretty much everything in Fem. So we'll be open the folder, find the folder, and we'll open Fem type. That's the Fem. Okay, and you should have the meshes here. And in the slides, I changed the color of them, so you can do that. And we will create two different type of joints. And for those three, there are the pin joints. Basically, they just rotate on 1 degree of freedom. And number 2 in the picture is a ball socket joints. It's like your leg that can rotate on 3 degree of freedoms. You can rotate anyways. So hopefully you know that. Now the first pin joint will be from the link to handle. So the RBE2 is to grab a mesh to the center node or the source node as it says. So once you grab the mesh into a center, then you can connect them using a C-bush. So that's why we have RBE2 and RBE2 on the side, and the plus sign plus the C-bush in the middle will create this pin joint. Okay, the C-bush is like your bearing. You can tell it to rotate on 1 degree of freedom. So it's a rotational joint, a pin joint. You can tell it to rotate on 3 degree of freedom, that'll be the ball and socket joint. Alright, so let's start. We'll hide the 2D mesh because we're doing everything here for the first joint. And you don't need the polygon. Okay, once you have the mesh, it's better to hide the polygons. Otherwise, in the simulation, you probably would apply your force and load onto the polygon, which is very bad. Okay, we have 2 collectors. So we'll start with the link or the connection bar, I think it's called in the slide. Okay, so we'll insert this. This is the spider actually. So 1D connection, and you need to define the element type to RBE2. Okay, there's RBE3, it's a little bit different. So RBE2 will rigidly connect every node into your source node. So you have source and target. The source is right in the middle. Yeah, we don't have a node there. So let's go back, turn on polygon. Actually, we just need the polygon for this. And we will need a node in the center as a source node for the link as well as for the handle. That means we need 2 nodes. And here's the node ID, for example, 1 and 2. So we insert a node, create. The reason to have polygon on the screen is so you can snap to the arc. Okay, that is the polygon. You cannot snap to a mesh because basically this is your CAD. Okay, and make sure this one is on invert. So snap to the arc. It'll find the center of your arc. That is 1 node. Apply, and I'll do another one. Say OK. Because we need to create 2 spiders, and their source node is coincident. Okay, so we'll hide the polygon since we're done with that. And we do have 2 nodes, but when we create the source we just pick one. How do we know if we have two there? Just hold your cursor a little bit while, then you can have this window. You can see we have two nodes there. But we'll start, just pick one. Target are those nodes. And the filter should be on no method by default. We'll pick them. And of course you can do a feature angle, feature element edge, but this edge sort of a big angle, so we'll just hand pick them. RBE2. Okay, so the source is in the middle. Targets is on along the edge. I'll change this to dark so you can see them. And auto creation, say okay. So that is one spider, which is called RBE2. Okay, RBE2 don't have any properties. If you do edit, so there's only the name you can change. So you can put them all in the same collector, or you can put them separately, so you can change the color of them individually. Okay, that's what I'm going to do. So this is for the link. I'll just say this link. Then I'll hide this. You still have one node left for the handle. So we'll hide the link and show the handle. Now here, I just grab 4 nodes each side. Okay, that'll be enough to transfer the load. And of course you can pick the whole thing. It's sort of messy. And I'm doing creating another RBE2 source in the middle, in the center. Target will pick 4 nodes each side. You can do a box too. If you have this thing like this, you can do a box and box. Okay, so auto creation, you can rename it right here when you do create a new collector. So this is handle. And okay, so now you can see it's a new collector with the name already given. Alright, now we can show the other RBE2 and show the mesh. So now we have 2 different RBE2s. I like them to have different colors, so edit display or change the color, maybe red, and change the line thickness. You can see a little bit different, maybe a little bit thicker. Okay, then the other one, so you can do any color you want. Okay, so now they are not connected, but they just simply grab the mesh around them. And now we will connect them using a C-bush, and that is 1D element. So we'll use it this way, insert element. It's actually the same as this 1D connection. You change this to C-bush. The only difference is here you have to specify a source and then target. And for C-bush, it doesn't matter which one is the source. So I'll insert element and create. See, as you can see, we have RBE2 here. So we need to create a C-bush. And here you just simply pick 2 nodes. And actually nothing will happen. Just look, take a look at the 1D collector when I pick them. So we have 2 nodes here. They are not connected. There are only one for the link, one for the handle. And I select one. Then take a look here on in the navigator. When I click the second node, we have this C-bush that is created. Okay, and this window is still open, but it turns back to 0. You can keep going for the next C-bush, but you're done with this one, and you can't see it. Okay, so you don't know if there's a C-bush there. So the next step is to show the name. Right click and edit display. Here you can check this text mark. Okay, you can also do apply first. That's a very little, that's actually not very little. That's the name. You can change the color as well. I don't know, anything. Apply. Okay, so the SP there stands for spring, and you can consider ZBrush as a spring on all 6 degrees of freedoms. The spring element we did in the first homework is actually just 1 degree of freedom. So this way they are connected through this ZBrush. And next we'll connect another joint. It's still a pin joint. Well, we're not defined. That's not defined yet. That's the property of the ZBrush. But maybe change this a little bit. Okay. So the same thing. You have some structure on the left side and one spider on the right side. Then connect them using a ZBrush. The only difference from the first one is this time we will connect the spider to a C bar, not another spider. So something like this. Okay, on the left side we have a pin that is welded on the handle through spiders, and on the right side we have a spider that is welded on the link. Then we will put a ZBrush between the center node of this pin and the spider, and we will tell the ZBrush this is a pin joint. It can rotate on top of this. Right, so that's the idea. Then we need to show the 3D connect the handle here. Okay, so the spider for the handle will grab only the top of this hole. We're not going to grab the whole thing. Okay. Yeah, it is a approximate, but this is relatively strong, right, compared to the nylon bar here, so it doesn't matter that much. All right, and we need to create a center node, the source for the spider again. So we need to turn on the polygon, and we also need a node in the middle. Actually, we need 2 nodes in the middle, one for the C bar, the other one for the spider on the link. Then we connect those 2 together. Okay, so let's create a node. Now that's the reason to rename your polygon, so you can find them in this scenario. Oh, man. Okay, that's good enough. So insert a node, create. Now we'll insert 2 nodes in the middle first. Okay, so we have one for the C bar, one for the link, and one on the top for spider, another one at the bottom for the spider as well. And here you need to click OK. If you click apply, you need to click cancel. Otherwise you will have 2 nodes. Okay, apply will create a node, and OK will create another node. So we're done with the polygons. We just hide them, and we need to create the spiders. The 1D connection spiders, we do the one on the link first, source, the target. So here it's a little bit messy. We'll hide the 3D first, and then pick the nodes. Okay, that's the target, and we already have a collector for the link, so you can pick from here. The destination collector will be this, and we do apply, and as you can see, it'll automatically follow the color and the line thickness of that collector. Okay, so that's same as the other spider. And next we will create the spider on the 3D handle for the top. So again, source in the center, target, those nodes, I'm a little bit tired of picking them. So feature edge nodes, they're on the edge. And because the edge is at pretty big angle, you can't really bleed all the way around the hole. And I believe I selected some edge in the background. Well, looks fine. So we'll keep selecting them. Switch a little bit so you can see the little circles here. Then okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that looks good. And all right, now here we need a new collector because that's on the handle. Of course, you can put them all in one collector. Personal preference. And this one is handle, the other one is jaw handle. Well, we'll all put them in handle then. Okay, so handle here, apply, and do the same for the bottom. Target this node, target, feature edge nodes. You pick one edge, it'll pick two nodes, or you can play with the tolerance angle. Try if it will go around the hole, because that's bigger than 30, smaller than 45. Now apply. You got two spiders that goes into a C-bar. So C-bar with two sections. So you have a node in the middle that can be connected to the spider on the link. All right, now we have two nodes in the middle. How do we know which one that we needed for the C-bar? It's easy. You can hide the C-bar, or hide that spider. It'll hide the node on the spider as well. So if you hide that spider, you only got one node there. If you show the spider, it'll show the node on the spider. So you have two nodes. So make sure you hide it first. And we're done with the 3D. That's really all you need. It's like your skeleton. Once you have this connection, you don't need the 3D on the screen. So we will insert the element to create the C-bar. And you don't want to put in the bar collector 1. I think that one is for the nylon bar between jaws. So we'll auto create another one. And you can rename the collector. We'll start from the top to the middle. Then for the second section, you can add them to existing mesh, which is this one. And sometimes you need to make sure that is the right one. Okay, so collector 2 mesh 3, and this is mesh 3, because you can, well, that's in collector 2, so you only have this one mesh. From here to the bottom, and close. So this whole bar is in this mesh 3. Okay, now let's show the RBE2 in the middle. And it looks like they are connected, but actually they are two separate things. And this on the screen now it's all welded from the handle to the C-bar because they share a node, okay, between the elements. But between the red spider to the C-bar, there's nothing, no connection. You have two nodes there, and they're not connected whatsoever. So the next step is to insert this C-bush here to connect them and to enable the rotation. Then we'll insert element, create C bar, and we should put this in the first collector of the C bush because it's the same type of joints, that is the pin joint. Okay, and you do not want to add to existing C bush. Okay, you want a new mesh, so make sure this is a new mesh. C bush, collect one and select two nodes, or pick one and pick two. You have a new mesh here. You're done with this connection, and close. So that is a pin joint. This is another pin joint. The red will rotate on the C bar here. The red will rotate on the purple spider. That is all because of the SP. The C bush acts as a bearing. So the last pin joint is between the handle to the lower jaw. Okay, and it's again a different type of shape, but it's the same mechanism. This lower jaw will rotate on the handle. Okay, so for the spider on the lower jaw, we simply grab the top surface, and for a spider on the handle, we'll grab the whole cylindrical face. Okay. Now let's create a node for the spiders. So show the polygon, and I'll hide the mesh just so you know we don't need a mesh to create, or we actually need the polygon to create the center node for the spiders. So create, and find the center for the top, then find the center for the bottom hole. Then we're done with the jaw here. Now trying to hide it. Okay, now we need to find a node right in the middle of this cylinder. So it's a little bit tricky. It's not a single node, right? What we do is we click this node dialog. Then in here you have an option to create between 2 points. So between the, actually you can between this node and the other node. That's right in the middle. Or you can do it between this center of the top edge and center of the bottom edge. It's the same thing. And say OK. So it found the node in the center. You can see the Z is 0, that is on XY plane. And click OK. Now we have 3 nodes. Actually, we need 4. Right? Remember, we need one node for the C bar, the other node for this spider, and they are coincident in the middle. So we need to insert another node, and this time simply grab the node in the middle. It'll create another node on top of that. You can see we have 2 nodes. All right, so the nodes are created. Then we don't need polygons. Then we need, first is the handle. Yeah, let's do the lower jaw first. 2 spiders, top and bottom. So spider source in the middle, and target around this hole. Let's take a look at this filter. It's still 45. This is a very smooth hole. You can take this back to default value. Then feature edge nodes. Pick the edge. It'll pick the nodes on around this edge. RBE2, we need a new collector because it's another part. So it's actually lower jaw. So L jaw here. Apply. And do the same for the bottom. Center node is the source. Target. feature edge nodes around the whole lower jaw. Okay. Now we can change the display a little bit, and let's do, I have no idea. Okay. And for the handle, so let's find the handle. We can hide spider here, hide this. So we have two nodes. We will use one node for the spider first. Source node, just pick one. And the target are the cylindrical face, are exactly, to be exact, the nodes on the cylindrical face. So this time it's not an edge. We need to use feature angle nodes. The angle means the angle between elements. So this time you're picking up elements or element faces. And the angle between them should be smaller than 30 degrees in here. So you can change that, but that default is good enough. Once you pick a element face, it'll bleed out to all the nodes on the face here. And RBE2, so we'll put this in the handle collector, apply, and as you can see, this spider is sort of messy. Okay, it goes all the nodes around this hole and cancel. And we're done with that, so you can hide the handle, hide the spider here. You still have one node left, which goes to these two spiders for the lower jaw. Okay, so we need to create a pin here, and with the center node providing the connection to the handle. So insert element and C bar, and again we need a new collector because it's a different diameter. Okay, so we already have two bar collectors. This is third one. Then this also add to existing, and now this is welded to the lower jaw, and it's not connected to the RBE2 on the handle. Then here we need to insert this bushing to enable the rotation and connect them. So insert element, create C bush. Okay, you should be very good at this now. Collector 1, because it's the same revolute joint, rotation joint, pin joint, the same thing. Okay, they only rotate on 1 degree of freedom. So we need to pick two nodes and create a new mesh, by the way. This is very critical. Create a new mesh every time for the C bush. And you need to pick two nodes, and they're right in the middle. So it's better to zoom in so you don't pick those nodes here. Just pick those two. Okay, and close. Then we have three bushings. If you show all the 1D collector, you can see that that's the nylon bar, and we have three rotational of the 3 pin joints there. Then we're done for the pin joints. Next step is the ball joints. Okay, it's the same structure. The only trick is the property of the C bush. So in terms of making them, it's the same. Now we need to find the handle and sliding block. Okay, we'll connect, I think that's the bottom of the handle to the bottom of this sliding block, and we'll try to create a node between them. Yeah, F8. So for this node, this is really eyeball this node where this is. There's no center of the arc here. So what we do is we insert a node. This time just click right in the middle, and as you can see, the Z is 0. That's good. The only thing I require is put Z at 0, because we want everything happens on the symmetry plane. And so if you did a F8 before you insert, it should be on the equals 0. If not, just change this value and say OK. So that is one node. We'll do that again. Insert a node, create at exact same spot. So we have two nodes, one for each part, then connect them using the CBush. Okay, so again, RB2 source, one of them, target. I'd like to, so I picked the 4 nodes at the corner. Oh well, we can do that. And no method, you're just picking up single node. If you want to distribute the load a little bit better, you can select more nodes along this face. Okay, but we're looking at the whole model, so we're not worried about the localized stress. You will generate a bigger stress because you only have 4 nodes here. And RVE2, and also in the handle collector, which is good, so just do apply. Alright, now we have this spider and we need to create another one. So before you create, you want to hide that so you don't have 2 nodes on screen. Now we make sure there's only 1 node for the source node here. And for the target, we have a lot node, I guess that is along the edge. So what you can do is you can do feature edge. We'll pick this edge or this edge. It's not picking up the edge. So what we do is feature angle node. This angle is pretty small, so I need to modify that to 5 degrees. I just want the node on this flat surface. So that is the edge, and that's the angle. We'll pick that as well. So pretty much all the nodes along this alley here. Okay, then this is a sliding block, so it's a new thing. We'll do slide new collector. Okay, so change the color to black. It'll be very sharp here. If you change the background color. Okay, so hide the mesh. We just need 1D, and we need to connect those two together using a CBush. And again, insert element, create for CBush. And this time, remember to create a new one, because this is a ball joint. As you can see here, it's free on degree of freedom 4, 5, 6. It's different from the pin joints. So make sure you create a new collector, select both of them, and you're done. See, this one's here. And you can't see SP because we didn't turn on that yet. So edit display and check the text and change a color. What color should I pick? Well, that's sort of hard. Line width. Yeah, the color is not good. This. Oh well. Alright, so you can change the background. It'll change the color of things. Alright, that's connected, and the model is assembled. The only thing is it doesn't know which way to rotate because we haven't defined any of the C-bush yet. So we will define the C-bush right now. And how do we define these three are pin joints? You can right click on the C-bush collector, go into edit, and edit its bushing property P, bush. Okay, so here's a stiffness, and take a look at the coordinate system. On the Z direction, you want it to be able to rotate. So we'll leave Z rotation to 0. That way it can, there's no stiffness on Z rotation, it'll rotate on Z. Makes sense. Now the other stiffness will be 10e to the 7 or 8, the same. So I'll copy them this way. This collector will be only rotating on Z direction, which is along the pin. Okay, here and okay. And for the second C-bush, between these two, the handle and the sliding block, it is mostly it's rotating on only the direction, but it could in real life rotate on the other directions. So we decided to go with a ball joint. You go edit this collector, and I still have that in the Control C. So it cannot translate, but will allow rotation on 3 other directions. And okay. So you can't see anything, but these 3 are pin joints. This one is a ball joint. And there's one more thing you need to do for the C-bush, is the those 2 nodes we picked. One is source, the other one is target. But since we picked 2 nodes, so I'm sorry. C-bush, those 2 nodes, they're coincident, so they don't have a direction. It's just 1 point, and they don't. C-bush does not know the direction of your coordinate system. So if you you need to go select the 1D mesh, and we can actually multi-select the bottom as well by holding down Control key, 1 click, then right click, edit mesh associated data. Then here you have to do a coordinate system overlay. If you don't do that, your C-bush does not have a coordinate system, meaning it doesn't know X, Y, Z. That is funny, but you still have to do it. Okay, apply change to all of them. If you do this for a single one, you wouldn't have this checkbox here. You only have enable or which coordinate system you want to use. Okay, so again, nothing happened, but now it knows, okay, the X, Y, Z is the same as the absolute X, Y, Z. And that's all for the C-bush. Then we have some pin diameters you need to do. It's the same step as this one. And I hope you know how to do that, because I'm gonna skip that. And the 2D mesh thickness, and you should know that as well, because we did homework. But I'm gonna show you how to do that. So for this one, right click edit, mesh edit, here default thickness 0.125 for the link, and the material is steel. Okay, so library material, find the steel, and okay. So 2 things you have to do for 2D mesh, material and the thickness. Okay, then for the second one, material steel and thickness 0.375. Okay, and nylon bar that is the material for the C bar we created in lab 1. So it's not here, we have to pick it. Nylon, and we have the section there. Okay, you need to create a section for these pins, and that is a slide for the C-bush stiffness, and this is for the coordinate system. So check 2D mesh normal. Yeah, so about that, if you do a glue, right, remember in the last lab, if you do a glue between 3D to 2D, okay, 3D mesh is fine because it's the normal direction of your mesh is always pointing outwards from on the 3D. But 2D is a little bit tricky. You don't know which side is normal, which side is top, which side is bottom. And when you do a glue, you will need to pick top or bottom. So we need to take a look at the 2D normal, which is in here, 2D element normal, and select these two. Display the normal direction. As you can see, it's not the same. And when you do a glue, you want to make sure you pick. You want to make sure you know you're picking up top or bottom. So we need to reverse the one at the bottom here. Deselect the top. Reverse the normal direction. Okay, so it's pointing towards the 3D mesh. Now we can do another check. So they're both pointing towards the 3D mesh, and this is the top surface of the 2D mesh. Okay, so when you do a glue, you will say, I want to glue the top of this 2D to the top of the 3D. Then that's the process. And that is for the next lab. Okay, so in this lab, you should have the, let's see, all the joints done, all the materials assigned, the thickness for 2D assigned, the radius for the pins assigned. Okay, so that is this is everything assembly here. Okay, it'll make the mesh, connect the mesh together. Alright, so that is all for the second FEM lab. We'll meet in the third. Thank you.